Okay, so we'll go over these. So first off, let's look at what the answers are. Alright, so 87 is C. No, 87 is D, sorry. 87 is D. 42% of people got that right. 88 is C. 62% got that right. 89 is E. 32%. 90 is A. 30%. 91 is C. 64%. And 92 is B. 45%. Huh? Okay, so let's go over them. So 87, this is the one that was on your take-home test. An object traveling in a straight line has position x of t at time t, and the initial position x of 0 is 2. The velocity, they give you the velocity equation. What's the position at time 3? So to get position at a certain time, you have to take the initial position, or where it was at when t was 0 at the start, and add the total change in position over whatever time period you're talking about. So in this one, the initial position is 2 plus, and then to get total change in position, you integrate velocity. Velocity is the derivative of position, or it's the rate of change of position. So if you know how something changes and you want to know the total amount it changes, you integrate. So we would integrate from 0 to 3, because we're looking at what the position will be at 3, the velocity equation. And that'll give us the total. So, and we have the two calculators real quick. So we would do 2 plus the numerical integral from 0 to 3 of the cube root of 1 plus, and you can use t or x, doesn't matter. Whatever you use, though, you have to put the same variable over here. And so you should get 6.512, which is D. If you put 4.512, then you just forgot to add the 2. And so that's probably the most common wrong answer to give, would be C. And that just means that you knew to integrate velocity to get change in position, but you neglected that it didn't start off at 0. It started off at 2. Alright, 88. The radius of a sphere is decreasing at a rate of 2 centimeters per second. So this is a related rates problem. It's from last semester. It's old. This is dr dt. The rate of change of the radius with respect to time, and it's decreasing 2 centimeters per second. At the instant when the radius is 3 centimeters, what is the rate of change in square centimeters per second of the surface area of the sphere? I'm going to call that just, I guess, ds. dt is how many square centimeters per second. And they give you the formula for the surface area of a sphere. It's 4 pi r squared. So we take the derivative of that with respect to time, and we get ds dt equals, the only variable over here is the r, so we take the derivative of r squared, it's 2r, and we'd multiply by this constant 4 pi, so we'd get 8 pi r dr dt.
Wait, why did you do that again?
Because we're taking the derivative, so we take the exponent, bring it down to the front, multiply by what's there, the 4 pi, and subtract 1 from it. Right? And then because we're respecting time with our derivatives, and neither of our variables were time, we have to put the ds dt and dr dt. So then we can just plug into this. So 8 pi times 3 times negative 2. So negative 48 pi. It's been a while since we did those. It's like last semester. All right. 89. Okay, so on 89, this is basically kind of testing whether or not you remember a theorem. So the function f is continuous on the interval negative 2 to 2, and f of negative 2 and f of 2 are both 0. Just a second. I just want to make sure that I knew what their age was. If there is no c in that interval where the derivative at the point would be 0, then which of the following statements must be true? Okay, so there was a theorem that we talked about called Rolle's theorem that said if you have a function that is continuous and differentiable on an interval, there were two requirements, that and the endpoints of the interval had the same the endpoints of the interval had the same values. Then there exists a value in that interval such that the derivative at that point is 0. So basically what it said was this: if you have a function that starts and stops at the same height, that the only way to connect those 2 points with a nice continuous differentiable function is to make it so that someplace the slope would be 0. I could try to connect them just with a straight line and the slope would be 0. Or I can try to go up and then come back down, but up here the slope would be 0. I can go down and then back up, but down here the slope would be 0. There's no way for me to draw any line from here to here without drawing a place where the slope would be 0. So basically that's what that's saying. But here's the thing. They said it was continuous, and they said that the endpoints had the same height, but they didn't ever say that it was differentiable. And that's a requirement. So it's E. There's got to be some place in the interval where the derivative doesn't exist, where it's not differentiable for this to not be true. This would be one where I would be comfortable missing it. I just think that it's a lot of effort to memorize the theorems and what they mean for them to be in like maybe 1 or 2 problems on the test. So if you remember the theorem and it makes sense to you, then that one's not too bad. But if you don't, I wouldn't worry too much about it. Okay. The function f is continuous on the closed interval 2 to 4 and twice differentiable on the open interval 2 to 4 if the derivative at 3 is 2 and the second derivative is negative on the interval 2 to 4. Which of the following could be a table of values for f? Alright, so let's see. Alright, so this means that, okay, let me think about how to explain this for a second. Okay, so if I look at what's happening here, at how these are changing. Because remember, that's what the derivative and the second derivative are talking about. They're talking about the rates of change that are going on here. So if I look at the y values here, here they go up by 2.5, then 1.5. Here it's 2.5, then 2. Here it's 2, then 1.5. Here it's 2, then 2. Here it's 1.5, then 2.5. All right, the fact that the second derivative is negative tells me that this value should be decreasing. Like how much it goes up each time should be decreasing. Because the second derivative is referring to how much this rate of change is changing. So here it's 2.5, now it's gone down to 1.5. So this one could be it because that would give me a negative second derivative. It could be this one. Could be this one. It can't be either of these two. Because this one, the rate of change didn't change. It was 2 both times. And here, the rate of change went up. So it can't be either of those. So now if I look at this, this says that the derivative at 3 has to be 2. These are average rates of change, so the actual rate of change at 3 would have to be between these two. So it can't be either of these because 2 is not between 2.5 and 2. Right? It is 2. And it's not between 1.5 and 2 because it is 2. This 2 has to be between these two values here. Right? This is saying that the rate of change at 3 is 2. So if the rate of change on either side of 3 has to be on either side of 2. It's this one. This one's another one that's kind of tricky to explain. All right, 91, you just have to know the formula. The average value formula is this. And the a and the b come from your intervals. So we would do 1 over 3 minus negative 1 times the integral from negative 1 to 3 of this function. So I would do 1/4 negative 1 to 3 cosine x over squared plus x plus 2 dx 0.183. So let me see. Alright, and then the last one. A city located beside a river has a rectangular boundary as shown in the figure above. The population density of the city at any point along a strip, x miles from the river's edge, is f of x persons per square mile. Which of the following expressions gives the population of this city? Okay, so this one, we're measuring in from the river, x miles. So x is the number of miles that you are from the river's edge. So that value can be anywhere from 0 miles, you'd be right on the river, all the way to 4 miles from the river. So that'll tell you this dimension. But if we want to know the whole population, we would then have to multiply by this dimension, the length, right? Because the city's a rectangle. So if we integrate to get the width, because the width can vary depending on how far you are from the river, but the length will always be 7. So we would do length times width.